All right, here's our second example of balancing redox reactions. Let's again go ahead and go through the four-step process. Step one again is to divide into half reactions. So I'm going to go ahead and take my first half reaction here, which is going to be my NO2 minus yields my NH3. That's my first half reaction. And my second involves my aluminum yielding AlOH4. -1 as far as the charge is concerned there. So we've done that. Second thing we're going to do is we're going to start by balancing each half reaction. So let's start up here, balancing elements not O or H. And if you see, this is another example where in my first half reaction I have one N, that's fine, one Al. So I don't really have to do that first step here in the balancing that half reaction. Now we're going to balance oxygens by adding water and H's by adding H+. All right, so top example, I have 2 oxygens on the left, none on the right. So I'm going to go ahead and add 2 waters on the right-hand side to balance that. On the bottom reaction, this 4 does get distributed, so I have 4 oxygens on the right-hand side of this reaction. So I'm going to go ahead and add 4 on the left-hand side of this reaction, so 4 waters over here. So we've done our oxygens. Now we're going to go ahead and do our hydrogens. Balance hydrogens by adding H+. So let's take a look at the first example. No hydrogens on the left-hand side, and we have a bunch of them on the right. Let's go ahead and add all of these together. I have 3 plus 4. Be careful, that's a distribution there. 2 times 2 is 4. So 3 plus 4 is 7 hydrogens on the right. So I'm going to have to add 7 H pluses on the left. For my aluminum reaction, let's go ahead and add those together. I have, for H's, I've got 8 H's on the left, and I have 4 H's on the right. So I need to add an additional 4 H's on the right-hand side. All right. Next step is balancing charge. Now this is going to be a little bit trickier. We do have to be careful when we're balancing charge that we are adding things up correctly. So I'm going to go ahead and take my pencil here, and let's go ahead and figure out my total charge on this left-hand side over here. If I add that all together, go ahead and get a smaller pencil here. I have 7 positive charges and 1 negative charges, so my total charge here is 6 plus. Over on the right-hand side, if you notice, I have nothing. Charge is 0. So we're going to go ahead and add electrons, which are negative. So the side that's going to get the electrons is going to be the side that has the positive charge. So I need to add, in order to get it to equal to 0, 6 electrons on the left-hand side here. So I've done that for the top reaction. Now I'm going to look at the bottom reaction. Again, I think it's helpful to do this. On the left-hand side right now, I have a charge of 0. On the right-hand side, let's go ahead and add this all together. I have a charge of, let's see, positive 4 from the H pluses, and a negative 1 means my overall charge here is plus 3. So I'm going to go ahead and add a 3 electrons to this side. All right, so now we've done all of step 2. The last thing we're going to do here before we simplify is multiply to equalize electrons. So here's where we pay attention to the number of electrons in the top reaction, which is 6, to the bottom reaction, which is 3. In order to get these to equalize each other, we're going to go ahead and multiply each of these reactions, or the bottom reaction, excuse me, by 2. So I take this entire reaction and multiply it by 2. So this becomes an 8. This becomes a 2, an 8, and a 6. All right, so to make things a little bit simpler, I'm going to go ahead and rewrite those reactions. I've got my top reaction, 6 electrons plus 7H plus NO2 minus yields NH3 plus 2H2O. And then my bottom reaction, again, being really careful that I've multiplied everything by 2, 8 waters plus 2 aluminums yields 2 aluminum hydroxide ions plus 8 hydrogen ions plus 6 electrons. All right, now that I've done that, again, my favorite part, step 4, simplify and add the half reactions together. So let's go ahead and find some simplification. First thing I'm going to go ahead and do is cross out my electrons. And let's go ahead and start adding things together and simplifying. Now, one thing you're going to find is that we actually have H pluses on the left of this reaction and on the right of this reaction. That's what's called a side-to-side cancellation that we can do. So if I have 7 on this side and 8 on this side, all 7 of these are going to get canceled out. All of these but 1 will be canceled out. Okay, so we're always going to look for species that appear on the left and right side, and those can be simplified. The other species that can be simplified here, if we take a quick peek, is the water. I've got 2 waters on the right of this reaction and 8 waters on the left of that reaction, and so we can simplify that as well. So both of these are going to disappear, and this one is going to change into 6 waters. All right, now that we've got that, let's go ahead and see if there's anything else that can be simplified. And then we're going to go ahead and write our final reaction. So I don't see anything else that appears on the left and right. So we're just going to go ahead and put these together. 6H2O plus 2Al plus NO2 minus yields NH3 plus 2Al OH4 minus plus 1 hydrogen ion. And that is our final reaction.